This video is to derive and visualize the diagonal related properties of these quadrilaterals. By watching this video, you'll be able to visualize and recall the properties easily, and you need not to learn them a lot. So here let's start with the diagonals equal property, and we'll be starting with the parallelogram. Here we have a parallelogram, and we have to see whether the diagonals are equal or not. The layman method is to measure the diagonals, and you can find out whether the diagonals are equal or not. But the other way out is this, and by learning this you can easily recall the thing. Okay, just see, we already know that the opposite sides of a parallelogram are equal. Okay, here one of the angle is acute. You can see the angle here, this is 90 degree and this is less than 90, and the angle on this side, this is 90 and this is more than 90. Okay, so this angle is acute and that is obtuse, and these sides are equal. Now both the diagonals are starting from here. Okay, but this diagonal has to travel a long distance just because of this obtuse angle. Okay, it has to, because the side is not acute, so it's somewhat like this. It is an obtuse direction, so this diagonal has to travel a long distance, whereas here the angle is less than 90, so the side is somewhat like this. It's not like that, so this diagonal has to travel less distance. So both started from here, but one has to travel less distance, the other has to travel more distance. That means the diagonals are not equal in a parallelogram. Okay, so the all game is about the angles here. Okay, similar is the case with the rhombus. Let's see this. So both the diagonals are starting from same point, but this angle here is obtuse. This is 90 degree and the angle is more than 90. Starting from here, crossing 90, more than 90, and here the angle is 90 here, but this angle is less than 90. So this is acute, that is obtuse. Okay, because of obtuse angle, the side is like this, and this diagonal has to travel more distance. Okay, whereas this diagonal, just because of acute angle, is traveling less distance. So in this rhombus here, this diagonal is smaller than this. So diagonals are not equal in a parallelogram and in a rhombus. Okay, so you got to know that this is the game is all about the angles. Now let's see, here we have a rectangle. Okay, so here both the angles are 90 degree. You can see that. So both the diagonals are starting at one point and they are ending at the same point. Okay, no one is traveling more distance. So just because of these 90 degree, the diagonals are equal in a rectangle. And similar is the case with the square. In a square also, the diagonals are gonna be equal, because here the angles are 90 degrees, so both diagonals are traveling the same distance. So we got to know about the diagonal related properties of these four quadrilaterals. You can use the same angle one technique to find out whether the diagonals are equal in trapezium and in kite or not. So let's fill this. Diagonals equal in a parallelogram? No. In a rhombus? No, just because of angles. In a square, the angles are 90 degrees, so yes. In rectangle, the angle are 90 degrees, so yes. Now let's derive the next properties, which are these. Diagonal bisect each other, this and that. For this, we will take a parallelogram, and first we will prove, let's prove that the diagonal bisect the vertex angle or not. Okay, that means, see, this diagonal is emerging from this vertex and ending at that vertex, and when we drew this diagonal, it divided this angle into two parts. So diagonal bisect the vertex angle means whether these two angles are equal, these two are equal or not. Okay, so when we see it here, they might seem equal. Okay, so whenever you have to compare two angles, you have to see it a little farther from the vertex. So let's draw, let's see it this far from. So now do you find that this angle is equals to this angle? Are you finding these two angles same? Initially you might find them same, but here it's quite clear that the angle does not bisect the vertex angle in parallelogram. Same is the case with on this side also. Okay, so this angle is quite bigger and this is quite small, and here this is small and this is big, no? Okay, so this is so that's clear that diagonals do not bisect the vertex angle in a parallelogram. Okay, there is another way to look at this. Look at this. If you are able to fold, if you are able to overlap these two angles, if this could be overlapped over this, if this angle could be overlapped over this angle, that means they are identical, because identical things overlap. My hand I can overlap like this, no? So they are identical. Here can we overlap these angles? So we are trying overlapping by folding it on the crease of the diagonal. Okay, and let's see whether they overlap each other or not. So you can see they're not able to overlap. This portion is left, this portion is left, this is able to overlap it till here. So this is able to overlap it till here. That means this portion is equals to this is extra. That means diagonal do not bisect the vertex angle in a parallelogram. So this overlapping technique can also work. Now how to remember it for other quadrilaterals? So you would be able to overlap these two angles if this side could be overlapped over this, but this side is too small, this side is too big, so actually it's going out. We cannot do this, no? So that's the one way out. The quadrilaterals in which this side can be, the adjacent side can be overlapped over the other adjacent side, in that the diagonal bisects the vertex angle, but these two sides are not equal. So from here you can take an idea which all quadrilaterals can bisect the vertex angle. Okay, so here can you overlap this over that? Yes, they can be overlapped because these two sides are equal. These two sides are equal. You can see that. No, nothing is left here. Both the angles are overlapped. So these two angles are equal. And why they are equal? Because adjacent sides are equal in a rhombus. So diagonal bisects the vertex angle in rhombus and in square. Even here you are able to overlap because these two sides are equal. Okay, but in a rectangle again you cannot overlap them. You can see this angle is quite big, this one is quite small. So we studied about whether the diagonal bisect the vertex angles or not. So here is this. Do they bisect in parallelogram? No, because the adjacent sides are not equal. In a rhombus, yes. In a square, yes. In a rectangle, no. Okay, the same technique can be used to find out whether the diagonals meet at 90 degree or not. See, this is parallelogram and both the diagonals are meeting at this point here. We have to find whether these angles are 90 degree or not, and for that you need not to find out every angle to be 90. See, if you can prove one of them is 90, suppose this is 90, then you can prove this is also 90 because vertically opposite. And once this is 90, so these two are linear pair, so 90, and this is also going to be 90. Okay, and vertically opposite, this is 90. So you need to prove whether any one of them is 90. If you can prove that, then you will say that the diagonals meet at 90 degree in a parallelogram. Okay, now one way out is just measure, make a parallelogram and measure. Okay, but we cannot do that every time. Okay, so the simplest way to learn, as I promised in the beginning of the video, if you can overlap this triangle over this, so what will happen? Can you overlap them? If you can overlap, then this angle is gonna be equals to this, if you can overlap like this. Okay, and if these two are equals, if you can prove them xx each, so if they are same, so they are linear pair also, their sum is 180 for sure because this is a line. So this is 180, and if they are same, you can say both are 90° each. Okay. So we just need to prove, we need to see can we overlap them, but you can see these triangles are quite different, no? And so these two, because of these sides, the triangles are quite different. Okay, these seems equal here, this is also same, but because of these two sides they are quite different. So this cannot be overlapped over this, which means this angle is not equals to this, so you cannot call them xx. So this is y. So the two angles are different. If the two angles are different and the sum is 180, that means both are not 90° each. So you cannot overlap them like this just because of these sides. So diagonals do not meet at 90° in a parallelogram. Similar is the case with the rectangle. You cannot overlap these two triangles, these adjacent triangles, just because of this and that side. They are different. No? They still look fine. These two still look same, but these are, you cannot overlap them. So diagonals do not meet at 90° in rectangle also. Okay, these two angles are not equal, so they cannot be 90° each. But in a square, you can overlap these two triangles because these two sides are equal, and also in a rhombus. So the angles here are equal. You can check that also. See, this angle is 90. So this is 90, this is vertically opposite. Then this is linear pair to this, means all are 90. Similar is the case with the square. Here we have a rectangle. Let's keep it here. You can see this angle is obtuse. This is 90°. This is less than 90, and this angle here is more than 90. Got it? And same is the case in the parallelogram. This angle is less than 90 because 90 was this. So we proved one more property, that diagonals meet at 90° in a rhombus and in a square, but not in rectangle and not in parallelogram. So these both properties is just because of this overlapping. If you can overlap these two, that means these angles are equal and these angles are also equal. That means diagonal bisect the vertex angle and diagonal meet at 90°. And that's true in case of when the two sides are equal. So you can remember these two properties like that. And for diagonal equal, you have to focus on the 2 points from where the angles are starting. And if they are 90°, then diagonal will be equal. Now the third one, diagonal bisect each other. For this, let's start with the parallelogram. Diagonal bisect each other means this diagonal has got divided into two parts, and the two parts are just because of this diagonal, no? Because we drew this diagonal, that's why this got divided into two parts, and we drew this diagonal, that's why this diagonal got divided into two parts. Now we have to see whether these parts are equal. Is this equals to this and this is equals to this? So for this we need to cut this triangle out. This cannot overlap like this just because of these two sides are not equal. Okay, but there is a way to overlap them. So let's cut it. So here I have cut it. We cannot overlap it like this. You can say they are not overlapping, but we know this angle equals to this here. No, these two are interior alternate. So if we have to overlap, I just need to flip this like this. Got it? Because this angle can be overlapped over this. So I'm just turning this angle there. Okay, just need to flip it. Okay, let's do it like this. Got it? Now can I overlap them? Yes, they are exactly same. I'm able to overlap them, and just see this piece of the diagonal is overlapping over that piece. Got it? So diagonal actually bisect each other in a parallelogram. This piece is equals to that piece. Got it? Similarly, this piece is also equal. So in short, diagonals bisect each other in a parallelogram. Rhombus is also a parallelogram. So diagonals will also bisect in this square, in square also, in rectangle also. This was all about the properties of diagonal properties of these quadrilateral. Rest you can derive yourself. Thank you.